Hi everyone. So today's section we're looking at May June 2023 Physics Paper 2 Variance 3. Now the first question is this. The first question we have a well has a depth of 36 meters from ground level to the surface of the water as shown in the diagram. When you check the question, now the distance between the surface of the water and the well, the surface of the water and the ground is 36 meters. So a student wishes to find the depth of the well. The student plans to drop a stone down the well and record the time taken from releasing the stone to hearing the splash made by the stone as it entered the water. Assume the air resistance is negligible and the stone is released from rest. That's the first keyword. The stone is released from rest. So initial velocity of the stone is 0, is released. It wasn't thrown with any form of velocity. The word release means the initial velocity is 0. So calculate the time taken for the stone to fall from the ground. This is the ground, this place is the ground. From the ground to the surface of the water. The time taken to fall from the ground to the surface of the water. We are going to apply SUVAT. Now, the parameter given the question, we are given the height or the depth of the water from the ground to be 36 meters, one parameter. The other parameter is initial velocity, which is 0. And we are looking for the time taken for the stone to strike the surface of the water. It's not given, it's unknown. And remember that the stone is falling freely, which means the acceleration is the gravity, which is 9. In physics, we use 10 meters per second squared. Now, which SUVAT equation combine these variables together? We have H, U, T, and A. So we're going to use this S equal UT plus half AT squared. Already our S, the distance, is the height, 36. It's falling from rest, U is 0. We are looking for the time, plus half A is G, which is 10. We're looking for the time, T squared. So from here, you're going to have 36 equal 0 times T is 0, half GT squared. This one gives 5T squared. So from here we have, let's make our T the subject of formula. So T squared is 36 over 5. So T will be square root of 36 over 5, which gives 2.68 seconds. That's the time taken for the stone to fall from the ground level to the surface of the water. Now let's move to the next question. The second question, the time recorded by the student, the time recorded from releasing the stone from the ground, to hit the surface of the water using a stopwatch, is not equal to the time in A. Now mathematically, what we got here, the first question, 2.68. But when the student tried the experiment using a stopwatch, the question said it's not equal. So the question is suggest 3 possible reasons other than effect of it or air resistance for this difference. Now, the question asks us to suggest what might have caused this issue. Mathematical time wasn't the same thing as experimental time. Now, one of the major reasons that can cause this might be reaction time. Now, what's mean of reaction time? Having reaction time between hearing the splash and stopping the stopwatch. That's one of the reasons. Let me write it down. Reaction time simply means reaction time between between hearing the splash and stopping the stopwatch. Reaction time is all about when to stop the stopwatch or when to start the stopwatch. So between hearing the splash and stopping the stopwatch. If you don't do it on time, it might bring about some error. That's one of the reasons that might cost it. Now, the second reason is most likely zero error. Now, as you all know, zero error is always as a result of an instrument that is not properly calibrated. Which means there's some instrument that's supposed to start from the zero. They either start above zero or below zero. So which means all your time taking, all your recording might be higher on one direction or lower on one direction. So zero means not properly calibrated. Not properly calibrated instrument. Not properly calibrated instrument. Sorry. Now, one of the reason, the third point might be assigning initial velocity for the stone. The question said the stone was released from rest, which means that you're supposed to take the initial velocity to zero. If you assign an initial velocity to the stone, which means the time will not be correct. So stone given an initial velocity. Stone given an initial velocity, or initial velocity is not zero, yes, or initial. Once your initial velocity is not zero in this context, then your time will be wrong, is not zero. These are the possibility that might have caused the error recorded in the laboratory. And the third question, the C part of the question, the student repeat the experiment 3 times and uses the result to calculate the depth of the well. The values are shown. The student repeated the experiment 3 times. The first experiment, the student got 54.4. Second experiment, 53.9. Third experiment, 54.1. Now, the true depth of the well is actually 36 meters, as shown in the first question. Explain why this result may be described as precise but not accurate. Now, what is the meaning of precision? Now, when the results agree with each other, when the values are close to each other, we can say they are precise. But when the values are far away from the true value, they are not accurate. So which means when you check, the actual height or the depth is 36 meters. When you check these 3 values, they are far away from 36 meters, which means they are not accurate. But the 3 values agree with each other, which means they are precise. So in this case, let me put it down like this. It's not accurate. it's not accurate because the values recorded is far away from the true value. Is far away from the true value. Is far away from the true value, but the readings or results, the reading or result is precise because they are close to each other. They are close to each other, or they agree with each other. That is the meaning of precision. So with this point, you get your full mark, 2 marks. The next question. Okay, this one is fluids or physics of fluids, density of thrusts. Now this question, a sphere floats in equilibrium. Remember, at equilibrium, remember the word equilibrium. All the forces toward the right, toward the left are equal to each other. Summation of vertical forces is equal to summation of horizontal forces. All the vertical forces are equal to 0. All the horizontal forces are equal to 0. Now, a sphere floats in equilibrium on the surface of the sea. Now, the density of seawater is given to be 1050 kg per meter cube, as shown. And again, we have the density of the water. Look at the sphere. According to the question, 21% of the volume of the sphere is below the surface of the water. 21% of the volume of the sphere, which means the percentage of the object displacing the water is just 21%. Remember Archimedes' principle. Archimedes' principle states that when a body is partially or wholly immersed in the water, it experiences upthrust equal to the weight of the fluid displaced. In this case, the body has been partially immersed in the water, which means the upthrust by the water will be equal to what? Weight of the object. So the upthrust by the water will be equal to weight of the object. Now, this is all about Archimedes' principle in play. When the body is partially or wholly immersed in a fluid, it experiences upthrust. The object experiences upthrust equal to the weight of the object. So in this case, when you check the front page of the data page side, we have some formula given there. That's it. It should be given there the formula for upthrust. If it's not given, we can also derive it. Okay, it's given. This is the formula for upthrust. Upthrust is equal to density multiplied by gravity times volume. So, like I said, the upthrust by the water, what's the formula for upthrust? Density, gravity, volume equals the weight of the object. What's the formula for weight? Mass times gravity. Weight of the object. So in this case, we have density of the water multiplied by gravity is constant. The volume in this case is 21%. That's 0.21 volume. That is what is in use, equal to mass times gravity. Gravity cancels gravity. the question asks us to calculate the density of the sphere, that's the density of the object. So from here we have density of the water multiplied by 0.21 volume of the object used in this question equal to mass. Remember that density is mass over volume. So mass will be density. This one is all about the object. So the mass in question will be density of the object times volume of the object. So volume cancel volume. So the density of the object in this case will be density of water multiplied by 0.21. So density of water is 1050. So 1050 multiplied by 0.21. Let's see what we're going to have. So 1050 multiplied by 0.21. So we have 220.5. It can be 220 or 221. Is accepted. That's the question. That's the answer to that question. Now let's see question B. Now question B, the sphere is now held so that its entire volume is below the surface of the water. The sphere is now held so that the entire volume is below the surface of the water. This is what the question is talking about. Remember, the sphere is now held so that the entire volume of the sphere is below the surface of the water. It's not at the surface, it's below the surface of the water. So the sphere is then released. Calculate the initial acceleration of the sphere. Calculate the initial acceleration of the sphere. Now, there's some condition you need to take note about this question. Now, what is the density of the water? It's 1050. And what's density of the object? The density of the object is 220. Obviously, the density of the water is greater than the density of the object. So, since the density of water is greater than density of object, which means that the upthrust in this case will be greater than the weight. The upthrust is produced by water. So in this case, the upthrust will be greater than the weight, which means if the upthrust is greater than the weight, the object will tend to move, as you're trying to pull it down, you're trying to move upward. Now, we have two forces in this case, the weight of the object and the upthrust produced by water. Upthrust is going up, the weight is coming down. We have two forces, upthrust and weight are both measured in Newton. So in physics, what do you do when you have two or more forces acting on an object? What do? You find the resultant force. In this case, since the upthrust is greater than the weight, so to be upthrust minus weight. So resultant force, according to Newton's second law of motion, resultant force is mass times acceleration. Remember, the upthrust is from the water. Upthrust is density of water, volume times gravity, minus weight. Our weight is mg. Weight is mg, and mass is what? Density times volume multiplied by gravity. Remember that for weight is the object, so this is for object. So from this case, like I said, resultant force is what? Mass times acceleration. In this case, what's the mass? The mass will be density of the object multiplied by volume, because it's the object that is accelerating. So the mass here will be for object. So multiplied by acceleration equal to density of water, Vg minus Vo, density of object Vg. In this case, volume is common. So divide through by volume. So what do you have when divide? So we have density of object multiplied by acceleration. Let me write the density in the clear. So from here, I have the density of the object multiplied by acceleration. Volume has cancelled. What left here? Density of water multiplied by gravity minus density of object multiplied by gravity. We are looking for acceleration. Make acceleration the subject of the formula. So that will be density of water minus density of the object multiplied by gravity divided by density of the object. So we can now use the expression to find the acceleration. So density of water is 1050, density of object is 220, multiplied by g, g is given as 10, divided by density of object 220. Mix it up, calculator. 1050 minus 220 divided by 220. We need to have 37 meters per second squared. That will be the acceleration of the object. If you have any question, you can put it in the comment section. That's it. Now the next question. Is the sphere accelerate upwards but remain entirely below the surface of the water. Like I said earlier, the sphere continued accelerating upward, but the sphere never exceeded the surface of the water. State and explain what happens to the acceleration of the sphere as its velocity begins to increase. It's a very good question. So in this question, remember the question said that the sphere remain entirely below the surface of the water. Okay, let's say skeleton diagram. This is the water. This is the water here. And this is sphere. The fact that the sphere is accelerating upward will never escape or exceed the surface of the water. This is the acceleration, accelerating upward, which means that there is a drag force dragging the sphere backward. So in this case now, in this context, let's list the initial forces. As you all know, we have the upthrust force, we have the weight of the object, which is downward, upthrust is upward, and also the third one now, this is the weight, the third one is a drag force. So in this case, what will be the resultant force now? We have three forces acting on the object. The forces are upthrust, upward, weight downward, drag force downward. But since the direction of the sphere is accelerating toward the direction of upthrust, so the resultant force will be upthrust minus upward forces minus the downward forces, because the resultant acceleration is upward. The downward forces are weight plus drag force. And so what the formula for resultant force according to Newton's second law of motion, mass times acceleration, equal to upthrust minus weight plus the drag force. Now this is the model to break down this theory. This is the model. Now let's go back to the question. It said, state and explain what happens to the acceleration as velocity begins to increase. Now there's a relationship between drag force and velocity. You are not supposed to know it, but just have it at the back of your mind. It's not compulsory you cram this formula. The formula for drag force is half this coefficient density A V squared. So drag force is proportional to V squared. That's what this relationship is all about. So we have a relationship between drag force and velocity. They are proportional to each other. So the question asks us, state what happens to the acceleration of the sphere as velocity begins to increase. Now, since drag force is proportional to velocity, As velocity increases, drag force also increases. Drag force also increases as velocity increases. Now, if the drag force increase, what do you expect? What will happen to the resultant force? Okay, let me take this back as resultant force. Let me interpret it. Let me write it as it's still the same as RF. So when drag force increases, what happens to the resultant force? Resultant force decreases. How? Let me give you an example. Now, let's assume our obtuse is 6. Assumption. Our weight is constant, doesn't change. Let's assume it's 2. Let me put a value for drag force. Let's assume the first drag force is 1. In this case, what will be our resultant force? It will be 3 Newton. 6 minus 3, 3 Newton. When the drag force increases again, remember that obtuse is fixed 6, the weight is fixed 2. Let's increase its drag force to 2. What happened to our resultant force? So 6 minus 4, that's 2 Newton. You can see as the drag force is increasing, resultant force is decreasing from 3 to 2. Let's confirm one more value. Now the drag force has increased to 3. What will be the resultant? 1 Newton. You can see now, as the drag force increases, resultant force decreases. Since according to Newton's second law of motion, if resultant force decreases, what happens to the acceleration? Acceleration also decreases. So let's put it down. As velocity, as the velocity increases, comma, drag force in the liquid, also increases. Drag force is proportional to v squared, also increases. Hence, resultant force decreases. Since force is proportional to acceleration decreases. This is what the examiner is looking for. That's it. Let's move to the next one. Now, number 3 question. Now state the principle of conservation of momentum. State the principle of conservation of momentum. Okay, it's 2 mark. So the principle states that in an isolated system, comma, the total momentum before collision must be equal to the total momentum after collision. The key words: in an isolated system. That's 1 mark. Total momentum equal before and after collision. That's another mark. That's it. The next question. A firework is initially stationary. It explodes into 3 fragments, A, B, C. You know the way fireworks work. You know, it's scattered in different dimensions in air. Well, according to these questions, it explodes into three fragments. The fragment as shown, A, B, C, that moves in a horizontal plane, that move in a horizontal plane, as shown in view from above in figure 3.1. The fragment A has a mass of 3m, as you can see, and move away from explosion with a speed of 4 meters per second. This fragment A, the mass is 3m, the speed is 4. Fragment B, the mass is 2m, the speed is 6. And fragment C, the mass is m, that will move away at an angle of theta. So the question is, the first question, see it, pre-maths, we are asked to find angle theta. Okay, now in this case, since we are asked to find angle theta, we have two direction in this case. In this diagram, I can see the vertical direction. I can also see the horizontal direction. Now the first thing I would do, look at fragment C. Fragment C move away from the explosion with a velocity of v at an angle theta. So we need to resolve the velocity at an angle theta into horizontal component and vertical component. Generally in physics, when the variable is at an angle, you are supposed to resolve them into two directions. So the question will now tell us or lead us which direction to use when solving questions. First, fragment C is at a particular angle. I need to resolve it. Okay. This is the horizontal part of fragment C, and this is the vertical part. Let me draw a skeletal diagram for fragment C. It looks like this. This is theta. This is V. This is horizontal direction, vertical direction. So sine theta equal to opposite over hypotenuse. So the horizontal direction of fragment C will be V sine theta, and the vertical direction will be V cos theta. Okay, you can see this one is going like this, this is going like this. The direction is key. In Cartesian, toward the left is negative, down is also negative. You need to be very careful of the signs. Now I've resolved it. So what else again do we need to consider in this question? Oh, the principle of conservation of momentum. Remember I said total momentum before collision equal to total momentum after collision. Now look at the keywords. A firework initially stationary. Initially stationary. So before it was 0. So after is when they explode. So now the after collision is what we're going to do now. So we are going to resolve after collision is divided into two segments, horizontal direction and vertical direction. Let me consider the horizontal direction first. Considering horizontal direction. Now, one of the horizontal direction is this. I remember the direction is toward the left, which is the velocity is toward the left, the mass is m. Momentum is mass times velocity. In this case, it will be the mass is m, velocity is minus v sine theta. That's one horizontal direction. Which other one is a horizontal direction? Okay, we check 3m. The mass fragment A is also horizontal direction toward the right. That will be positive. Mass times velocity. The mass is 3m. The velocity is 4. This is the total momentum after collision. in horizontal direction. Before collision is 0. Why? Because the question stated initial direction. The initial is stationary. So from this horizontal component, I can actually say minus mv sine theta equal to minus 12m. So minus cancel minus, mass cancel mass. So v sine theta can be 12. I'll call it equation 1. Now let me also consider the vertical direction too. Considering the vertical direction. Considering the vertical direction. Now, let me start from the vertical direction of fragment C. Like I said, look at fragment C. The vertical direction of fragment C is v cos theta down, that's velocity. The mass is still m. Mass times velocity. The velocity is minus v cos theta because it's downward. There's also a vertical direction for fragment B. It's going up. That's positive. 2m times 6 plus 2m times 6. I don't think there's any other vertical direction anymore equal to 0 because the momentum before collision is stationary 0. So from here, we can have minus mv cos theta equal to minus 12m. The minus cancel out, the mass cancel out. So what do you have here? V cos theta equal to 12. This is second equation. Now, the first question is we have to find the value of theta. Okay, it's quite easy. To find the value of theta, we need to apply the basic maths. We have two methods, but the most easier one, let's divide equation 1 by equation 2. The reason I'm doing that is, okay, you see it now. V sine theta equal to 12 is equation 1. Divided by equation 2, V cos theta is also equal to 12. At the end of the day, V cancel out V. Sine theta divided by cos theta is fixed, usually give us tan theta. That's the reason why I did that, because I know sine over cos is tan. 12 over 12 is 1. So theta with tan inverse of 1. What's tan inverse of 1? 45 degrees. So our theta is 45 degrees. Believe it's clear. Now, second question is to find V. It's like simultaneous equation. To find V, make use of either the first or second equation. Okay, let's use the first equation. First equation is V sine theta equal to 12. Anyone is quite good. Theta is 45. V sine 45 equal to 12. Make V the substitute formula. That will be 12 over sine 45. Sine 45 is root 2 over 2. Root 2 over 2. That gives us 24 over root 2. When you rationalize, that's 24 root 2 over 2. You don't need this anyway. At the end of the day, we have 12 root 2. If you put this in your calculator straight, you get your answer. So 12 root 2, 12 root 2 meter per second, or in decimal, we're going to have 16.9, which is still the same thing as 17 meter per second. That's it. Question C. The fireworks in B contain a chemical that has a mass of 5 grams. It contains a chemical. So the fireworks contain a chemical. The mass of the chemical is 5 grams. Mass of the chemical 5 grams. And chemical energy per unit mass. Okay, you need to be careful of this statement. Energy per unit mass. So energy per unit mass means energy per unit mass is 700 joule per kg. That's energy per unit mass. So the questioner asks us that when the firework explodes, all the chemical energy is transferred into kinetic energy. Show that the chemical energy of the firework is 3.5. So from here, since energy per unit mass is 700, so the energy is 700 multiplied by mass. So energy will be 700 times the mass is 5 grams. Convert it to kilogram. That's divided by 1000. So 700 times 5, 700 times 5 divided by 1000. So we have 3.5. So the chemical energy is 3.5 joule. That's it. Now calculate the mass. Since you have to calculate the mass. Okay. Now, since you have to calculate the mass. Already we have the kinetic energy to be 3.5. And we call that the firework explode into 3 fragments. It explodes into 3 fragments. So, and the total energy of the chemical energy inside the firework is 3.5. The total energy, so kinetic energy of the first fragment plus kinetic energy of the second fragment plus kinetic energy of the third fragment. That's the meaning. Everything gives 3.5. That's the meaning of the 3.5. And we call also that kinetic energy is half mv squared. So for the first fragment, so we have half. What's the mass of fragment A? Fragment A, the mass is 3m. Or the speed 4. The mass is 3m, half m v squared. The speed is 4. The second fragment B, rest B, the mass is 2m, the speed is 6. The mass is 2m, the speed is 6 squared. The third fragment F, the mass is m. The mass is m. Or the speed? That the speed is v, and we got the value of v here to be 17. 17 squared equal to 3.5. So from here, so we have 4 squared is 16. 16 over 2 is 8. 8 times 3 will give us 24n. 6 squared is 36. 36 divided by 2 is 18. 18 times 2, 2, that's 36n. Plus 17 squared, probably that'll be 289, divided by 2, 144.5, 144.5, and add them to equal to 3.5. So when you add them together, plus 36 plus 24, so we have 204.5 n equal to 3.5. The value of n, 3.5 divide 204. So n is 3.5 divided by 204.5. The value of n will give 0.017 kg. That's the value of n. That's it. Let's see the fourth question. Okay. For a progressive wave, state what is meant by frequency. So that's the definition of frequency. Frequency is defined as the number of oscillation as the number of oscillation per unit time of the source, as in the source related to the question you're talking about. 4b, a loudspeaker, a microphone, and a CRO, cathode ray oscilloscope, are arranged as shown. Look at the loudspeaker and the way the microphone is also placed. Now from here, the loudspeaker is emitting a wave which is detected by the microphone and displayed on the CRO. The first question is, now the time base on the CRO is set to be, for time base, 0.5 millisecond per centimeter, while the Y gain is 0.2 V per centimeter, and 1 centimeter is 5 boxes. So the first question is find the frequency of the sound wave. Frequency is 1 over period. Now what's the period of this wave? What's the period of this wave? Okay, period, let me enlarge the graph. So period, you can take a period from here to make it easier to this side. That's 1 cycle. So between, how many boxes do you have between this point and this point? Remember that 1 box is 1 centimeter. So 1, 2, 3, 4, 5. 1 box. 1, 2, 3, 4, 5. Is another box. 1, 2, 3, 4, 5. 3 box. 1, 2, 3, 4, 5. We have 5 boxes make 1 cycle, and 1 box is 1 centimeter. And according to the question, we have 5 boxes. Okay, we have 5 boxes, and from the question, per centimeter, that's 1 box is 1 centimeter. Per centimeter is 0.5. So period will be 0.5 because it's 1 centimeter multiplied by 4 boxes. So what do we have here? So 1 over 0.5 times 4, that's 2. Remember, there's millisecond beside it. So the millisecond is times 10 raised to the power minus 3. So which gives us 1000 divided by 2. So the frequency is 500 Hz. The second question, the amplitude of the signal received by the CRO. Amplitude, the vertical gain. Amplitude is about vertical. And per centimeter, the vertical gain is 0.2. So if here is equilibrium position, this is the vertical gain. So let's see how many boxes that make the vertical gain. Now, 1 box is 1 centimeter. It's from here. Let me enlarge it also. Let's start from here. 1, 2, 3, 4, 5. This is 1 box, 1 centimeter. 1, 2, 3, 4, 5. This is 2 boxes. Making 2 boxes. That's so the remaining one. 1, 2, 3, 4. It's not up to 1 box. Remember that for vertical, we have 0.2 volt V per centimeter. So 0.2 per centimeter. So from here, so 1 box, from here to here, 1 centimeter. Here to here, 2 centimeter. This is not up to 1 box. This is 4. 4 is 0.8. So all this from here to here is 2.8. So the amplitude will be 2.8 multiplied by 0.2. That gives us 0.56 V. That's the amplitude. The next question, C part. The intensity of the sound wave in B is reduced to a quarter of its original intensity. Is reduced to a quarter of its original intensity. The intensity of the sound wave, which means we have a new intensity, which means the initial intensity, let's say, is I naught. Now the new intensity has reduced to 1/4 of its original intensity without change in frequency. The frequency is constant. Assume that the amplitude of the signal wave received by CRO is proportional. The amplitude is proportional to the amplitude of sound wave. Sketch the trace that is now seen on the screen. Okay, now what's the relationship between intensity and amplitude? Intensity is proportional to square of amplitude, provided that the frequency is kept constant. From here we have I equal to Ka squared. When you make K the subject of the formula, we have I over A squared. So when you're comparing two quantities, it could be I1 over A1 squared equal to I2 over A2 squared. So from here, remember that I1 was I naught, and our first amplitude, the amplitude we got earlier, was 2.8. That's 2.8 squared. The second amplitude is 1/4 of the first amplitude. Or the second intensity is 1/4 of the first intensity. So I don't know the amplitude when the intensity is 1/4. So from here, I naught cancel I naught. So we have 1 over 2.8 squared equal to, so in this case, I have 1 over 4A2 squared. So when it cross multiply, at the end of the day, I'm going to have 2.8 squared equal to 4A2 squared. Make A2 squared the subject of the formula. So I'm going to have 2.8 squared over 4. So let's find the square root of 2.8 squared over 4. 2.8 squared divided by 4. 1.96. Square root of 1.96. We have 1.4. At the end of the day, the new amplitude is square root of this 2.8 squared over 4. So the new amplitude, when the intensity has been reduced by 1/4, is 1.4 centimeter. I'm using the centimeter as amplitude, not the V, because I'm going to sketch a graph. So the question asks us to sketch the graph. Now, the new graph we are talking about has the amplitude of what? 1.4. So what has changed in this part? The amplitude is 1.4. For the new graph, the amplitude is 1.4. Let's see what has changed. Assuming that the frequency is constant. Since frequency is constant, the period will remain the same as the period of the first graph. Period is also constant. Frequency is constant. Amplitude changes. The new amplitude is now 1.4. Let's sketch the graph. So in this case, the graph will look like something like this. Let's sketch the graph. Let me erase my former point. So let's trace the amplitude first. Now the new amplitude is 1.4. That's 1.4 centimeter. This is 1 centimeter. So here will be like 1.4. this space. Let's do it down also. Let's take it down to, this is 1 centimeter, 1, 2, this will be 1.4. So the graph will start from the axis like this. With the same, the graph will start here. We're going to start from 1.4, move to 1.4, go back to 1.4. Don't mind my diagram. Let me make it a bit okay. Okay. Should be from 1.4 back to 1.4 to 1.4 back to 1.4 somewhere here, so to 1.4. So this is where the graph of the new intensity will look like. Just make sure the new amplitude is 1.4. They have the same period and the same frequency. Okay, let's move to the next question. Next question. Now the next question is question D. A metal sheet is now placed in front of the loudspeaker as shown. A stationary wave is formed between the loudspeaker and the metal sheet. State the principle of superposition. Okay, this principle is when two or more waves meet at a point, the resultant displacement is the sum of the individual displacement. This is the principle of superposition. Next question. The initial position of the microphone is such that the trace on CRO has an amplitude minimum. Is now moved a distance of 1.05 meters away from the loudspeaker along the line joining the loudspeaker and the metal sheet. As the microphone moves, it passes through 3 positions where the trace has an amplitude. It passes through 3 positions, like I said, where the trace has an amplitude maximum before ending at a position where the trace has an amplitude minimum. Determine the wavelength of the sound. Now, the key to this question is it passes through 3 positions. It passes where the trace has an amplitude maximum before ending at position where the trace has an amplitude minimum. So I think it looks like something like this. And the question said they form a stationary wave. So here is antinode, node, antinode, node, antinode, node. I think this is what the question is all about. He said, let me repeat it again. As the microphone moves, it passes through three positions where the trace has an amplitude maximum, before ending, before ending where the position has an amplitude of minimum. It starts from amplitude and back towards minimum. This is the possibility of what the question is talking about. So how many notes do you have here? One note, two. This is 6 nodes. Distance between nodes to node is lambda over 2. So the total distance here is 3 lambda over 2, which will be equal to 1.05. So when you cross multiply, 3 lambda equal to 2 times 1.05. So our lambda is 2 times 1.05 divided by 3. So the wavelength is 0.7 meter. That's it. Use the answer in B and DI to determine the speed of sound in air. Speed of sound is F lambda. Our previous frequency that they mentioned, BI, is 500. The wavelength in DII is 0.7. 500 times 0.7, 350 meters per second. That's our speed. Number 5. A student set up a circuit with a battery, an ammeter, an ether, and a lag-dependent resistor, all in series. The battery has negligible internal resistance. The voltmeter is connected across in parallel with the ether. Complete the diagram. Like they said, a battery, ammeter, and ether are all connected in series. A battery, after battery, you can take it toward the right or toward the left. We have ammeter. They are connected in series. And also LDR. What is the symbol for LDR? Light dependent is the symbol for LDR. And also ether. What the symbol for ether is just a box and stripe it. They are all connected in series. Remember the question mentioned something. It said this is ether, this is LDR, this is ether. It said a voltmeter is connected in parallel with the ether. Then the voltmeter connected measuring the voltage of the ether. So complete the circuit and the arrangement. This is the circuit, the arrangement. The next one, the ether is made of resistivity. Resistivity of the ether is 1.1 times 10 raised to the power minus 6 ohm meter. The length of the wire is 2 meter and the cross-sectional area is 3 times 10 raised to the power minus 7 meters squared. So the reading on the voltmeter is 4.8 volts. So find the resistance of the ether. To find the resistance of the ether, but we are given the resistivity of the ether. The relationship between resistivity and resistance length and area is R equal to resistivity multiplied by length divided by area. So resistance of the ether will be 1.1 times 10 to the power minus 6. The length is 2, while the area is 3.8 times 10 to the power minus 7. Put it in your calculator, compute it, you're going to get 5.8 ohms. Now, second part, the reading on the ammeter. The reading on the ammeter is equivalent to the current in the whole circuit. You know, they are connected in series. Current in the whole circuit. Now, you can get the, since they are connected in series, current in ether is the same thing as current in LDR. So, which parameter is given to get the current? Since we are given both the voltage across, the reading on the voltmeter is 4.8, and where is this voltmeter connected? The voltmeter is connected across the ether. So which means this is the voltage of the ether. So V is equal to IR. Voltage is 4.8 of the ether. The resistance of the ether is 5.8. So current is 4.8 divided by 5.8. That gives us 0.83. This is the reading on the ammeter. This is the reading that will go through the circuit because the circuits are in series, so they are maintained by the same current. Fact C. The ether is replaced by a new wire. Okay. The new wire is made of the same metal as the wire. The new metal, the new wire it's made of the same metal as the wire. Okay, which means they have the same resistivity. That's the meaning. The former wire and the new wire, they are made of the same metal, the same resistivity, and has the same length. The length of the old one and the new one, the length are the same. So but a larger diameter. Between diameter of the new one is greater than diameter of the old one. So the resistance of the LDR remain constant. State and explain whether the new wire has a resistance that is greater than, less than, or the same as the wire in B. Okay. Now let's go back to this relationship. Resistance, resistivity over area. Let's go back to that. Now since resistivity and the length are constant, so which means the formula can be resistance equal to K over A. So resistance is inversely proportional to area. Remember that the new diameter is greater than the old diameter. So if diameter is high, area will be high, resistance will be low. So which means that the new wire has a low resistance. It has a less resistance from this relationship. Do you know why the new wire has a lesser resistance? Because it has a greater diameter from this relationship. The new wire has a less resistance or lesser resistance because resistance is inversely proportional to D squared, which is synnomial to area. That is the answer. The reason and your conclusion, 1 mark. The second part. State and explain whether the new reading on the voltmeter is greater than, less than, or equal to 4.8. Now, so you have to state and explain whether the new reading on the voltmeter will be greater than, less than, or equal to 4.8. Now, since the ether resistance, decreases now, from our conclusion in figure 1. So, since the ether resistance decreases, so it has a smaller portion or part of the total voltage because the load is not much. So it's going to be assigned a smaller voltage, add a smaller portion of the total voltage. So voltmeter reading of the new wire, is less than 4.8 volts. That's the conclusion. Let's move to the next one. Number 6. Define Young modulus. 1 mark question. Young modulus, the symbol is E. It's the ratio of stress is the ratio of stress to strain. That's Young modulus. Or you can just find the formula. Young modulus, stress over strain is allowed. The next question. A uniform wire is suspended from a fixed support. Masses are added to the other end of the wire. The variation of the length L of the wire with the force F applied to the wire by the masses is shown. The cross-sectional area of the wire is 0.95 mm². Determine the unstretched length. Unstretched means original length. And original length is when there is no force. From the graph, when there is no force, the length is 1.998 meter. That is, look at it from here. When there is no force, that's the length. Let's move to the next question. Now, for an applied force of 30 Newton, determine the stress. The formula for stress is force over area. That's the formula for stress. So, stress, the force is 30 Newton, or the area of the wire. If you remember earlier, previous part, I said the area is 0.95 mm². To convert millimeter square to meter square, multiply your millimeter square by 10⁻⁻⁶. Automatically convert it to meter square. To impute these numbers in your calc, you're going to give us 3.2 times 10⁻⁷ Pascal. Stress is measured in Pascal Newton per meter square. Strain. What's the formula for strain? Extension. Your strain is extension over original length. What's the extension? Extension is new length minus original length all over original length. So what's our new length? We are looking for the strain. Now, new length, when the force of 30 Newton is applied, the new length is 2.003. This is the original length, 1.998. So new length 2.003, original length 1.998 divided by original length 1.998. So let's do the calc. 2.003 minus 1.998, 0.005 divided by that. So we have 2.5 times 10⁻⁻3. That's the strain of the wire. Next question, which is the last question, number 7. Now, figure 7.1 show incomplete data for 3 flavors type of quark. Elementary charge is E. Now, up quark is +2/3. So anti-quark of this will be what? This is down quark. You know, down quark is always -1/3E. Why charm? C. Charm will be 2/3E. Charm and up quark are the same. The opposite, this will be this other side, and the right hand side will be opposite of the one on the left hand side. Opposite as in the sign, opposite sign. This will be -2/3E. This is +1/3E. And down, this one is also -2/3E. That will be opposite. Using the symbol given in table 7.1, state a possible quark combination for the following hadrons: a neutral baryons, Neutral is Newton, and Newton has no charge. The charge is zero. It's expected that the combination of the quark must give us zero. So what can we combine from this to give us zero charge? 2 over 3 minus 2 minus 1 is 1. No. Okay. The only way is to do up, down, down. Up, down, down means up is 2 over 3. Down is minus 1 over 3. Minus 1 over 3 is going to give us 2 over 3 minus 2 over 3, which is 0. Up, down, down will give us a neutral variant. Now, which add-on combination will give us a missing of plus E? Plus E means just one charge. Okay, most likely 2 over 3 minus 1 over 3. That will be 1 over 3. This is not plus E. Let's see 2 over 3. 2 over 3 plus 1 over 3. That gives us 1. So 1 up and anti down. So this combination will give us plus E. That's what we meant by this question. The next one. Quarks are fundamental particles. Electrons are in another group class of fundamental particles. State the name of this group. That's electrons are in another group class of fundamental particles. Okay, it's called leptons. Leptons. State the name of another particle in this group. Leptons go with antineutrino. Antineutrino or positon. That's it. See you in the next class.